Welcome to another deep dive. This time, we're going to explore something truly mind-blowing. Multi-agent cognitive architectures and dynamic knowledge graphs.
That's a mouthful.
It is, right? But trust me, the concept is even more fascinating than the name. Imagine like a whole team of super smart AI working together, each one a specialist in its own field, to help you with your research.
Yeah, it's like having an entire research department at your fingertips, all powered by artificial intelligence.
Exactly. Okay, let's break it down a bit. What exactly is a multi-agent cognitive architecture?
Well, think of it like this. It's a network of individual AI programs, each one kind of like a mini expert in a specific area. And these programs, they don't just work in isolation. They communicate, share knowledge, collaborate to tackle complex research tasks.
So it's like a team of AI researchers all working together, bouncing ideas off each other.
Exactly. And the brains behind this whole operation, that's where dynamic knowledge graphs, or DKGs, come in.
DKGs, okay. Are those like giant databases full of research papers and stuff?
They're kind of like that, but way more dynamic. Imagine a massive web of information that's constantly evolving, updating, making connections between ideas. It's not just storing facts. It's understanding how those facts relate to each other, how research trends evolve over time.
So it's not just about finding information, it's about understanding the context, the bigger picture.
You got it. DKGs can track research trends, identify new areas of study, and even highlight potential breakthroughs that we humans might miss because they can see connections we don't.
Whoa, hold on. Are you saying these DKGs can actually predict the future of research?
In a way, yeah. They use some pretty sophisticated algorithms, things like graph convolutional networks, to analyze patterns in research data. It's a bit like having a crystal ball for scientific discovery.
That's incredible. But how do these DKGs actually learn and update themselves? It's not like they're sitting there reading research papers, right?
Well, not exactly reading in the human sense, but they use techniques like recurrent neural machine reading models to process and extract information from massive amounts of text data.
So they are reading just in a super fast AI-powered way. That's some serious processing power.
Yeah.
But it can't all be smooth sailing, right? What are some of the challenges in building and maintaining these DKGs?
Oh, there are definitely challenges. I mean, you've got to integrate data from all sorts of different sources, make sure it's accurate, and keep up with the ever-growing mountain of research out there. It's a constant process of refinement and improvement.
Yeah, I bet. Okay, so we've got these amazing, constantly updating knowledge graphs, but how do researchers actually interact with them? Do you need to be a coding genius or something?
That's where Kickline comes in. It's a formal language specifically designed to help researchers talk to these intelligent systems.
Formal language, does that mean it's all like complex syntax and jargon?
It's more about being precise than being stuffy, you know? It's a way to translate those complex research questions into a format that the AI can understand and act on.
So it's like a common language, a bridge between human researchers and AI systems.
Exactly. Now, we don't have all the details on Kickling yet, but we can look at other formal languages used in computer science to get an idea. The goal is to have a clear, unambiguous way to talk to the DKG so that the AI knows exactly what you're looking for.
Makes sense. The more precise the instructions, the better the results.
Absolutely. And that precision is especially important when you're dealing with the huge, complex world of scientific research.
This is all starting to sound pretty amazing, but is this technology only for, like, big research institutions with tons of resources?
Not at all. That's the beauty of open source. Projects like Blue Mars and the DKG library are putting these tools in the hands of anyone with an internet connection.
Blue Mars, DKG library. Those names ring a bell. Can you give me a quick refresher on what those are exactly?
Sure. So Blue Mars is like the conductor of an orchestra, right? It coordinates all those different AI agents within the multi-agent system.
So it keeps all the different AI programs working together smoothly?
Precisely. And then the DKG library, that's a set of tools designed specifically for working with, you guessed it, dynamic knowledge graphs. It's like a toolkit for building, managing, and interacting with your own DKG.
Hold on. Are you saying anyone can potentially build their own DKG?
That's the power of open source. Anyone can contribute to these projects and use them to create their own personalized research assistants.
That's incredible. So we're not just talking about a technology for elite researchers. We're talking about something that could democratize access to knowledge and accelerate discovery for everyone.
Exactly. It's an exciting time to be involved in this field, that's for sure.
It sounds like it. Before we get too carried away, let's take a step back and recap what we've learned so far. We started with multi-agent cognitive architectures, teams of specialized AI programs working together. Then we talked about DKGs, those constantly evolving webs of knowledge that can connect the dots in ways humans often can't. And we touched on kicklang, the precise language that helps us communicate with these systems.
You got it. It's a remarkable convergence of AI, knowledge, and human ingenuity, all coming together to change the way we do research.
It really feels like we're on the cusp of a new era in research, one where AI helps us understand the world in ways we never thought possible.
Absolutely. And we're just getting started. In the next part of our deep dive, we'll look at some specific examples of how this technology is already being used in the real world.
I can't wait. Bring on those real-world examples. I'm ready to see how all of this translates into tangible benefits for researchers and for society as a whole.
You won't be disappointed. Stay tuned.
I'm still trying to wrap my head around all this. It's amazing to think about the possibilities. You mentioned real-world applications. Where are these DKGs and multi-agent systems already making a difference?
One area where we're seeing a huge impact is drug discovery.
Oh, interesting.
Yeah, I mean, developing a new drug is incredibly complex and costly, right? It often takes years, sometimes decades, of research and clinical trials.
Yeah, and there's no guarantee of success, even after all that time and money.
Exactly. But DKGs and multi-agent systems are helping to change that. They're accelerating the process, making it more efficient, and increasing the chances of actually finding effective treatments.
Okay, how so? Are they analyzing clinical trial data to identify promising candidates or something?
That's part of it. Imagine like a DKG that's ingesting information from millions of research papers, clinical trial records, patient data, all of it. It can analyze that data and spot patterns, make connections that human researchers might miss.
So it's like having a super-powered research assistant that can comb through all that data and identify potential drug targets, maybe even predict how effective they'll be.
Yeah, exactly. And it goes beyond just identifying targets. It can also help predict potential side effects and even personalized treatment plans based on a patient's genetic profile and medical history.
So we're talking about personalized medicine, tailored treatments based on an individual's unique biology.
That's the direction we're headed. It's really exciting to think about the possibilities.
It really is. But drug discovery is just one example, right? Yeah. What other fields are being impacted by this technology?
Well, another really fascinating application is in material science. Researchers are using DKGs and multi-agent systems to discover new materials with specific properties like strength, flexibility, or conductivity.
You mean instead of just experimenting in a lab, they can use AI to predict what kind of materials might exist and how they might behave?
Exactly. It's like having a virtual laboratory where you can test out countless possibilities before you even start mixing chemicals in a lab.
That's incredible. It sounds like that could revolutionize entire industries from aerospace to electronics to manufacturing.
It really could. And the possibilities don't stop there. This technology has the potential to impact pretty much every field of research.
This is also fascinating, but I have to ask, are there any limitations to what these systems can do?
Well, of course, AI is still a tool. It's only as good as the data it's trained on, and it can't replace human expertise entirely.
Right, so garbage in, garbage out, as they say.
Exactly. It's about using AI to enhance human capabilities, not replace them altogether.
So it's a collaboration, not a competition.
Precisely. Humans are still needed to ask the right questions, interpret the results, and guide the AI towards meaningful discoveries.
It sounds like a powerful partnership, combining the strengths of both humans and machines.
It is, and we're already seeing the fruits of that partnership in fields like drug discovery, material science, and many others.
You mentioned earlier that these open source projects are helping to make this technology more accessible. Can you talk a bit more about that?
Sure. Open source projects like Blue Mars and the DKG library have been instrumental in democratizing access to these powerful tools.
So it's not just big tech companies or research institutions that can use this technology. Anyone can contribute to these projects and build on this work.
Exactly. It's a community effort, with researchers and developers from all over the world contributing to the advancement of DKGs and multi-agent systems.
It sounds like that open, collaborative approach is really accelerating innovation in this field.
It definitely is, and it's making these tools more powerful and versatile than ever before.
Okay, so we've seen how DKGs and multi-agent systems are already making an impact in areas like drug discovery and material science. And we've talked about the role of open source collaboration in driving innovation. But I'm curious about the bigger picture. What are the long-term implications of this technology?
Well, that's a question that researchers are actively exploring. We're just starting to glimpse the potential of these systems, but it's clear that they have the power to transform the way we do research, the way we learn, and even the way we think about intelligence itself.
Now you've really got me intrigued. I can't wait to dive into those bigger questions.
Let's do it. In the final part of our deep dive, we'll explore some of those long-term implications and try to envision what the future holds for this exciting field.
Okay, I'm ready to dive into those long-term implications. Where do we even begin?
Well, one of the biggest questions, and maybe one that's on a lot of people's minds, is how this is all going to affect the future of work.
Yeah, that's a big one. I mean, when you hear about AI that can analyze massive amounts of data and make complex decisions, it's natural to wonder if your job is going to be taken over by a robot someday.
Right, that's a common concern, but I think it's more helpful to think about it as a shift in the types of jobs that humans will do, rather than a complete takeover by robots.
So maybe not so much about losing jobs, but about jobs changing.
Exactly. Lots of jobs involve tasks that are repetitive or data heavy, right? Those are the kinds of tasks that AI is really good at, and those are the ones that are most likely to be automated.
That makes sense. But then what happens to the people who are doing those jobs?
Well, that's where things get interesting. As AI takes over those more routine tasks, it frees up humans to focus on things that AI is not so good at yet. Things like creativity, critical thinking, problem solving, and jobs that require a lot of human interaction.
So we're talking about a future where humans and AI work together, each doing what they're best at.
Exactly. It's all about finding that right balance, that synergy between human and artificial intelligence. And I think that's where the real potential lies.
I like that. It's not about humans versus machines. It's about humans A&D machines working together to achieve things that neither could do alone.
Precisely. And we're already seeing glimpses of that in some industries. Take healthcare, for example. AI is being used to analyze medical images, help with diagnoses, things like that. And that frees up doctors to spend more time with patients, providing that human touch that's so important.
That's a great example. Okay, so work is changing, but what about education? Could this technology transform how we learn, too?
Absolutely. Imagine a world where every student has a personalized AI tutor powered by a DKG that's constantly learning and adapting to their individual needs.
Whoa, that sounds incredible, like a tutor that knows exactly what you need to work on and how you learn best.
Yeah, exactly. It could identify your strengths and weaknesses, personalize lessons, give you feedback in real time.
Okay, but what about human teachers? Would they just disappear?
I don't think so. I think the role of the teacher would change. They'd become more like mentors, guides, facilitators, helping students navigate the learning process and fostering those skills that AI can't teach, like critical thinking and creativity.
So it's not about replacing teachers, but rather giving them tools to be even better teachers.
Right. And it's not just about personalized learning. DKGs could revolutionize research, too. Imagine having instant access to all the latest research findings, all connected and easily searchable.
That would certainly make research a lot more efficient and collaborative. Okay, so we've talked about work, education, but this whole conversation makes me wonder about how we define intelligence itself.
How so?
Well, if AI can do things that we used to think only humans could do, like analyze complex data and make decisions, does that mean it's becoming intelligent in the same way that humans are?
That's a really deep question, and honestly, I don't think anyone has a definitive answer yet.
It's a bit mind-blowing to think about.
It is, but I think it's important to remember that AI is a tool. It's a tool that we humans created, and it's only as good as the data we feed it and the goals we set for it.
So even as AI gets more sophisticated, it's still up to us to use it responsibly and ethically.
Absolutely. And I think that's one of the biggest challenges and opportunities we face as we move into this new era of AI-powered research and discovery.
Well, this deep dive has been incredible. It feels like we've only just scratched the surface, though.
We definitely have, but I hope this conversation has given our listeners a better understanding of this incredible technology and its potential impact on the future.
I think it has. And to all our listeners, thanks for joining us on this journey into the world of multi-agent cognitive architectures and dynamic knowledge graphs. It's a complex topic, but one that's worth exploring and discussing. Who knows what amazing discoveries await us in the future? Keep those minds curious, and we'll catch you on our next deep dive.